What were those?
Positive.
Positive,
Continuous.
continuous, and decreasing. So let's just make a little argument for each of those things before we bother taking the integral. Why could we argue that this thing's always, that the terms are always positive?
Ellen
is always one.
Does that mean another graph?
A little bit more care. It's always positive once I get beyond 1, right? Because if you think of the little ln graph,
You're only dealing with positive numbers.
it looks like that. So there are negatives for ln, but we're starting at 2. There's 1. So from 1 on, this is always positive. This is always positive. This is always positive, and a positive divided by a positive will always give me a positive. So we can make that argument. I'm going to shortcut it to say this. And say that we've discussed that sufficiently. But if you had to write something on the test, you might have to write something out for me that says why it's positive. Continuity. Why do I know this thing's continuous?
Because it goes just from 2 to infinity. And there's no, you already eliminated the factor of having
So it's vertical.
Okay, no vertical asymptotes because we're starting from 2 and going on. So multiplying n times or x times ln of x, as long as I've gone beyond 2, there's no vertical asymptotes, there's no holes, so I'm in good shape there. So I'm just going to say that we considered vertical asymptotes and holes, and there were none for x, or I'll go for n greater than or equal to 2. So that's sufficient. Decreasing.
I don't think it's decreasing.
It's not decreasing.
You from what, like, better be decreasing.
It is.
Can't, yeah, we can't apply the integral
From-
test.
from
Infinity,
right.
Negative.
Decreasing
From right to left.
Decreasing the
Now wait a minute. I'm looking at this function.
I mean, the bottom is blowing up, so that means the function's getting smaller.
You can't go that. You never had such a discussion about decreasing. In Calc 1,
test it.
yes, you're going to have to test it. And we have the
Derivative?
first derivative. If the first derivative is less than 0, I'm in great shape. So here I get to throw in a little review of old derivatives. If I was going to take the derivative of this, oh, I wouldn't have. You know what? I would have turned it into a chain rule situation. But if you want to do quotient rule, you can. If it's me, when I look at this, this is what I see. And then I do a chain rule on it. But if you prefer quotient rule, have at it. Take the first derivative. Let's see what you get. Say what?
Yeah.